it's John Maxwell, the day after our class, and this is a video to summarize it. The topic will be primitive data types, and it's a supplement to the reading in the IMAX system and the videos that you watch on AP Classroom. Well, let's get started. For some of you, this is the first time that you've looked at an actual program. I know there are students without programming experience or only experience in another language, so please be patient. Those with a bit more advanced knowledge, there'll be nuggets to pick up here as well. Okay, well, you know, not talking about primitive data types, but just in general, I want to point out that all Java programs begin with a class statement, public class, and in this case I call it first underscore day. So every Java program is written within a class context, a class file. And you'll notice one of the common mistakes of rookies is to name the file something other than the class name. That will result in a confounding problem you may not get to the bottom of, but please just use the same name as the class for the file name. And you can see up here I've called it first underscore day. The other thing that is convention, not a rule, is that classes start with a capital letter. So you can see mine, first day, also begins with a capital letter. The other thing to talk about is the main method here, which is public static void main, and in parentheses, string square brace args. Basically, for the first semester, we're going to create a lot of programs that are going to have this method in it. And in the second semester, we may have other programs that do not have a main, but I do want to tell you that every software system has a file with a main method, and this is the starting point to the Java software system. And in this case, it's not really a software system, it's just one file, but like the compiler will look for the main method in most cases, and then your program will start. So that's important to know, and you have to type it pretty much exactly the way it's highlighted here in order to get your programs to start. There are other examples, graphic programs in particular, where a main method is not utilized, but those are advanced and beyond the scope of the class. Okay, so responding to a question last night, we had a very intelligent answer, and I asked, what's this about? And it is declaring a constant. The word final indicates that. Static we'll talk about a little later, but like the person responding to it had a very astute answer to it. But I'm just going to focus on the word final here, and a little later on we're going to use a variable called bus capacity. Also create a scanner object, which is something that'll allow a user to input values from the keyboard, and I'll show you how that works. But in order to use the scanner, we import a particular library. So Java is full of libraries. We'll explore quite a few of them this year, but some of them need to be imported in order to be utilized in your program. So there's literally thousands of libraries, and you can Google the term Java API, and you'll get a document that will list all of the libraries in the Java language that can be imported. Now, there is a standard beginning library that you don't need to import, and it includes the primitive data types that we're going to talk about. Okay. One of these primitive data types is called an int, which classmate responded is representing a whole number. It's a number without a decimal point. And so You can see how I use the scanner input that I declared up here to allow the user to input the next int from the keyboard console. An int is a number of total items. In this case, I'm setting up a scenario where you can figure out the cost of, say, an inventory item. And it's called int. Notice how I name the variable starting with a lowercase letter, and if I need to use a word in there, I'll throw in a capital like total items. That's a standard convention. Again, a convention that programmers do, and I think you want to join the crew. Okay, so follow the convention, and your coworkers or your classmates or your teacher will appreciate it. There is another primitive data type called a double. A double is a real number, and so it will be any number with a decimal point. And those are typically like the cost, which is a currency item, okay, the rate of something occurring, and a number of other examples of what might be put into a double. And so you ask, do I have to differentiate between an int and a double every time I want to use a numerical value? And the answer is yes. And know the differences and why you would be using them. There is a third type of primitive data type that we're not going to really focus on tonight. It's called a boolean. And again, a response from the class last night said it holds a true and a false. And so boolean play again equal true sets play again to true so the game can start, but like we're not going to really use it in this program. Booleans are used in if statements. Later on we'll learn them so that you can make a decision if average above 90, okay, first honors, decisions like that. Or in looping, you know, while x is less than 10, keep the loop going. And those will be Boolean values, not necessarily put in a Boolean type variable. But that's something down the road. So let's run this and see. I prompt systemout.println total items, enter cost. I enter it in, and then I do a calculation, which is total items times item cost. And so I'm just going to run that. I'm going to say I have down here at the bottom of the screen 105 items. Very well. And the cost is 34 cents. And so it comes pretty close. You can almost guesstimate that it's 35.7, which would be $35.70. I want to point out that, like, okay, there's not a trailing zero. It's not 35.70. In this course and in the AP course, we don't need to worry about formatting as a currency or putting trailing zeros in where they make sense. It's simply just using systemout.println and outputting the calculation, which is done here. Okay, and that's the calculation. So you notice the asterisk sign there. That means multiplication. So I put a little comment here. There's plus, an asterisk, and division, and percentage are math operators. And you can make up any mathematical expression, and you can use variables within them, and there are some exceptions that you need to follow. However, they follow a rule PEMDAS. A little later we'll explain why there's the extra M, but I asked last night and somebody said the percentage sign means remainder or modulus or modulo. New word, modulus. It just means remainder. So when 4 divided by 3 goes in, it goes in once, but there's a remainder of 1. And then I asked a follow-up question, how many hours and minutes is 100 minutes? And the response was 1 hour, 40 minutes. And I said, you just use modulus in your head, or remainder. You said there's 1 hour, surely 60 minutes, right? And then there's 40 left over, so it's 1 hour and 40 minutes. Modulus comes into play more than you think. And I want to give you a warning, the College Board loves to try to trick you with modulus type operations buried within a deeper subject matter. So be astute on modulus, and we'll talk about this again. So I'm going to move on. Uh, Somebody noted that this is a comment that double slashes for a single line, and this is a comment too. It's not an operator. So I want to comment real number here. But there's also a multi-line comment, which is right here, and it begins with the slash asterisk, and all the way down the bottom it's an asterisk slash. And so I want to show you some of the other stuff. I don't want to show you all at once, so I'm going to remove this and Control X and put it up here, and then comment this part out and get rid of the wayward thing here. Notice the little red X that shows me in the Eclipse system that I'm working in that there's something wrong with this line, but it's actually the line after. I got to remove the comment. Okay, so I want to put this in to continue our discussion um, of modulus. Okay, and I probably shouldn't have removed it down at the bottom. I'll put it back in. And I'm just going to focus in on lines 18 through 21. Okay. And we have a scenario where students are making a class trip, and the chaperones are wondering how many can we put on buses and how many will ride in the chaperone car. And the bus capacity, as you reminded of, is a final integer, which is 45. They don't add no seats to the bus. Okay, there's no standing room only on this trip. So let's click and run it and see. Enter the number of bus kids making the trip. 93. 2 buses are needed for the trip, and 3 will ride in chaperone cars. Lucky them. Okay. So let's unpack this a little bit. 93 divided by 45 will lead to 2, because bus capacity goes into trip participants 2 times completely. However, the modulus, okay, trip participants modulus bus capacity will result in 3 that will ride in chaperone cars. Okay. You may ask yourself, wow, what if it's 47 kids? Okay. Or what if it's 89 kids? Okay, you're going to have a whole lot of people living in chaperone cars. I didn't say the code makes sense in all situations, but it does in the way that I set it up. And the reason why I set it up is I wanted to point out that modulus, and a student correctly identified, is in the order of operations at the same level as multiplication and division. So we added an M here for PEMDAS so that we could say that modulus actually lives on the same street or is in the same priority as multiplication and division. Okay, so PEMDAS. Okay, and at that point we wanted to have a little discussion about exponentiation. There's no operator of this list that exponentiates. Okay, here we use a math function called math.pow, which you do need to know for the AP exam. It raises 2 to the power of 8. And once again, we're talking about the powers of 2 in binary system. 2 to the power of 8 is 256. And someone correctly responded, when you have an 8-bit value, you actually equal 1 byte. So 8 bits equal 1 byte it will hold 256 different values between 0 and 255. So I think that's just kind of like a redo, not forgetting that what we had was a unit on binary arithmetic. So I'm going to move on. You know, I don't want this video to go too long. And I'm going to take this and talk a little bit about capacity. Okay. So there is a class called integer. And you can see as I hover it over in Eclipse, it gives you a variety of information about it. It's part of the java.lang, and I mentioned the import statement. Java.lang is not needed to be imported. Java.lang contains the primitive data types that we're exploring here in double and boolean, but it also contains some other classes like integer or double, capital I and capital D. So you may ask yourself, what's the max value of an integer? Okay, what's the capacity we're dealing with? And look, took a while without the comments, but somebody came up with roughly 2 billion and negative 2 billion for an int. And then I asked, is that satisfying? And people were like, no, not really. You know, because there are more than 2 billion people on this planet, okay? I think there's 7 billion, okay? So 8 billion, something like that. It's not going to work for our population. It's not going to work for a lot of values that should be whole numbers. There's no human that's a half a person, okay? So there's complexity, and likewise the max double, notice double dot max value is going out to e to the 308th place, okay, and e to the negative 324th place for doubles. And it's only accurate to 14 places really after the decimal point, which I mentioned that various applications like space flight, you know, astronomical values, really literally astronomy, astronomical values, and things right here on Earth, okay, are not easily captured in these primitive data types. As you move on into your discipline or advanced study, there are ways of handling this so that we can maintain fairly good accuracy while you know, dealing with large numbers. So not obviously the subject here, but at this point, guess what? It ties back to the hardware unit, because how many bits can a CPU take at one time, or how much can be traveling on a bus, which is a system that enables the movement of electrons throughout the computer system. Electrons having a charge, you know, either positive or negative, to represent, you know, binary values. You know, we are limited by our hardware architecture in programming. Okay, so do be aware of that. Again, I move the close down to give me the mouse. Here it is. Okay. And show you the next part of what I want to show you, which is just copy and do this. Okay, so I'm going to explore integer division a bit more, and we already gave you the idea of modulus, but I just want to highlight it because, again, I referenced the College Board trying to plunder you in the exam for not understanding integer division. it's I know it's wrong of them. So let me just say something is wrong. Let's see. That's the end. That's the opening comment. This is the opening comment. No, that's not the opening comment. This is the opening comment. What fun you get to talk to me while I try to figure out my comments. Something's wrong here. Missing a closing thing. There we go. Boop. Multi-line comments are great. Let's suppose you're like trying to code a solution and you go, this is all awful, but some of it's good, and I need to start again, but some of this code can be recycled. Rather than erase it, put it in a multi-line comment. And you can start again and pick and choose the types of code lines that you want to use and copy them up to the section you're retrying. So multi-line comments are very good. And multi-line comments form the basis of documentation, which if you're going to work as a programmer or on a software team, you want to document so that others can look at it. Nobody writes code anymore solo. This is no more a cowboy cowgirl situation where they're out on the software planes alone. It's a team, and so comments make a bit of difference. So here's the integer division explanation. Okay, we have the example 4 and y is 3, and we go 4 divided by 3. Okay, and we'll run it. 4 divided by 3 is 1 with a remainder of 1. Okay, but I want to say obviously this type of division only occurs when it involves two integer types. Okay, it doesn't apply to real numbers or doubles, only integers. And so this is where the College Board tries to trick you up a bit. You're looking at the division, you're looking and saying 4 divided by 3 is 1.333. You go ahead and make that the basis, but you forgot to check what the type of x and y were. And if they're two integers, you're only going to get the whole number. And so someone asked, okay, does it always round down? And I said yes, and that process is called truncation. Okay, so what happens when we take z, which is 3.0, and turn it into x divided by z? We get 1.33. So the minute a double comes into the division calculation, the result is a double. In fact, any calculation with any operation that includes a double always will result in a double. And so this special case is only applying to division between two integers. And if you try to get the remainder, in the past this wouldn't work, but I don't think you can get the remainder here. Let's see. You just get the remainder of 1.0. Take a look. Does provide the remainder, but in the form of a double. And I do want to say that about doubles. Again, what I wanted to say is that everything and every operation that includes a double is going to be resulting in a double. Okay, So let me comment this out, okay, by taking this and looking at our last topic. Hopefully this video won't run for too long. Oh my God, we're dying here. Okay. Alrighty. Let's get rid of that and say, I think it should go. No, I don't want to asterisk slash it at all. Okay. This is wrong. No, I got it right. Okay, on to a different division problem, okay? 10 students take a quiz, and the total of all their scores is 94. What's the average? And a student replied last night, 9.4. I said, very good. That is the average, but not with integer division. And take a look. Integer division will result in an average of 9. So if you were going to use that to curve or do anything that impact with student grade, there'd be a lot of objections, and it's just plain wrong. They did better than that. They were close to a 95 average, so that really does them harm, okay? Maybe not lasting harm, but the answer is to cast. And casting is just like it is in theatrics. You're you, but you are playing Hamlet on the stage, okay, or Lady Macbeth, and what happens is you're fulfilling that role. You're cast as it, but after the play, you're back to being you, okay? So what happens is we're casting total scores as a double, and total scores will revert to being a int after this line of code on 41. Line 41 gets executed, and that results in a 9.4 average, which is proper. So you cast one of the int variables to a double to produce a double result. Now, a lot of beginners will just cheat and make total score students a double, and then they'll get the right answer, and that would be fine. But like, it's not exactly right. There's kind of like this code, right? That says, hey, if it should be represented as a whole number, make it a whole number variable. Make it an int. And if it should be represented as a real number, make it a double variable. So the versatility of casting it, changing its type temporarily for the purposes of a calculation, particularly to avoid integer division, okay, is a common practice. So I want you to see that, all right? Now, again, that idea of truncate, total scores divided by students, okay? Even if total scores was 97, okay? Let's run it again. And it says it still rounds down to 9. Well, I shouldn't even use the word round down, because the formal word is truncation, to shorten, truncate your remarks, shorten them. And so it still comes down to 9, and that's tragically unfair. There is, likewise, here we talked about POW, and there is math, okay, and you'll learn about the math library functions that you need to know. I think you need to know POW, square root, and absolute, abs, squirt, and POW. The fact that you know round or seal or any of the other math functions, and there's tons of them, arctangent, cosine, all of them are in the math library. Google Java math API, and you'll see all the functions in the math library, okay? You only need to know 3 of them: POW, square root, absolute, and there's one other, math.random. You'll have to know these four for the exam. So math.round will round to 9. Okay, so let me actually cast it first, okay, and then run it. That will make it sense. It rounds to 10, and it follows the rules. Anything 0.5 and above will round up, and anything below 0.5 will round down. So there is an exercise on rounding, and so good you. Okay, now to finish, I just want to talk about this thing that we've avoided, the plus sign. Okay, and the plus sign isn't an arithmetic operator in this case. It's a joining operation between what's in the quotes and the operation, the math operation. Okay, it's called formally concatenation. Concatenation. Oh, it's briefly described as joining. So what it does is join what is in the quotes, also known as a string literal, a string, which is alphanumeric information. A lot of that going around in the world. You know, your name's in the computer, your address, stored as a string. Your age, probably an integer. Your GPA is probably a double. You know, your school computer contains a lot of information. String is an important data type, and we're going to learn it in a class or two. But here we go. The plus sign joins the string part to the calculation, and it will do it in order of operations. So it does the division first and then joins it to the string. So you gotta watch out if you have an addition inside the output statement, systemout.println, because unless you put parentheses around the calculation first, then it will join it in mistaken ways. So we'll talk a little bit more about output later. But for now, you'll find the file attached to a message that I'll send to you. Open it up in whatever compiler you want. Open it, copy it into your compiler. You can do it online. It should run. And you can fool with it if you want, or you can just review it. I'll uncomment everything, okay, so that it will run completely all the way through. So if you wanted to run it once. What am I talking about, running it? Okay, you watched it run, now you want to run it on your own. That's fine. Hope you enjoyed the video. There's likely one every